Hello everyone, my name is Luke Sanford and I'm here to show you a project that I made, which is a robotic sign language arm powered by a Raspberry Pi 4B. So to just give some overview of what I built, it's a robotic hand with 4 fingers, a thumb, and a little LED to let you know when the hand is supposed to be like that. It's all controlled by tensioned strings that then connect to 4 high torque servo motors, then feed up into the hand, up and over. Every single part in this project, which was 3D printed and laser cut, was designed by myself. I wanted to challenge myself and make all of the sort of files for the fingers and for the hand and the holders, just to see what I'm capable of, and I'm pretty proud. In terms of how it works, so it's a terminal operated program. So let's say I want to learn how to spell hello. So I go H-E-L-L-O. Let's add a little exclamation point on there. Then we're going to find
H.
It tells us how to spell each word.
L. L. O.
And then resets.
That is how you spell hello in sign language.
And I added a little bit of TTS using Piper TTS in order to get it to say whatever I'm speaking. And then I just loaded up the audio files for each individual letter to sort of help you learn. In terms of the code, I can get into that right now. Let me just open up in Vim. Overall, it's pretty simple. All I'm doing is the Blinka library with the Raspberry Pi. I set some global constants for what the up position, the down position, and whatnot is. I then have a letter mapping, which maps all of the positions to the sign language. That's just a Python dictionary. I set up my PWMs, my servos, my LED, then have a synthesized speech, which does all of the TTS stuff with Piper. I have play audio just to play the WAV files, spell word, which essentially just breaks down whatever the user inputted into all uppercase characters. It removes all non-alphanumeric characters, finds that audio file just by pathing to it, and then for each finger does a position, and if the thumb position is different than what it was beforehand, goes to that. The reason being for this is that the last servo motor that I needed didn't actually come in, so I ended up using a continuous servo motor in the thumb, which isn't as ideal because you have to rely on timing rather than exact positioning. But if you build it yourself, I'd highly recommend just using another high torque servo motor or even a smaller servo motor in there. You're free to edit the STL files that I include. I then have reset hand so that every time you finish a word, it goes back to its original position. And then a fun little thing I did was to make sure I had multi-threading so that when I start the process, one of the little threads will go off and do all the audio processing work, at which point I can spell the word so that by the time I'm all done, it essentially has no delay before saying what you asked. So yeah, I hope you enjoy. This was for Professor Gallagher's physical computing class.